Hello there. Here we are, our last lesson on rational expressions. We have been on a journey. We were introduced to rational expressions, and for those of us that didn't know, a rational expression is simply a fraction that involves expressions. X plus 2, x squared minus y equals 7. Those are those are expressions. And what we did, we put them in fraction form. That's why rational expressions. Rational, fractional, you get it? Anyway, we simplified, we multiplied, we divided, we add, we subtract. We add, subtract with like and unlike denominators. So I hope that this rational expression journey has been beneficial. I hope it serves as a tool for you to refer back to. And I hope that all my blurps weren't too bad. Here again, it was a technology thing. I tried to be as professional as possible, but sometimes technology makes us look like we don't know what we're talking about. It's all good. Anyway, I enjoyed the time spent with you. Just remember all those concepts. I please encourage you to go back and review, take notes, find some practice problems and see how well you can implement these different steps that I share with you. One thing about me as an instructor, I believe in giving my students word notes, not just numbers, words, so they can go back and read, they can refer to, they can use the steps that I share with them to make sure that they're doing it correctly. So I hope that everything I've shared with you in these past lessons were very beneficial. I hope that you are successful in your math courses from here on out. And I hope that you just continue to press on and strive to be the best you can be. And I also want you to stay healthy. Now, our lesson today is talking about solving equations containing rational expressions. We were talking about expressions the past couple lessons. They're going to be expressions, yeah, but they're going to be with equations. Remember, expressions, if you notice, there were no equal signs in anything we did in the past couple lessons, but you will begin to see equal signs because we're not talking about equations. And those rational expressions are just within the equations. So we're going to have to solve for a variable. And most of the time you can check your answer, but because of time, I'm not going to check everything, but the smaller ones that are not too involved, I will check some of them to show you how all that work does pay off. But I want you to make sure that you always, as you know, through most of my lessons, as I'm working through the problem, I always say, check where you are from that point to make sure you don't go through a whole problem and your problem is wrong. You're like, why is it wrong? If there's a way to check your answer throughout the process, do it. It just makes it more it's better at the end when you go, oh, I got it right, because you checked it along the way. Always stop and think. Look at your problem. Which way do I want to go? Think about the different rules you're going to encounter, different things. We saw product rule involved in there. We saw factoring. Factoring is a big thing. We saw those special circumstances like difference of squares. We saw difference of squares. What else did we see that was we know that has to factor into sum and difference, but there are different things that we had in there. Oh, when we took out a GCF, you had to do the quotient rule in some cases. So there's a lot of different concepts within one lesson that you have to remember. So my suggestion is use note cards, and as you're working individually, have the note cards laid out. So if you see something that, oh, your note card is right, you can refer to it. My thing is, the more you see it, the more it becomes permanent in your mind. So please do not always, oh, I got it. Going slowly, double checking is more effective than rushing through it and getting it partially correct. Okay? All right, so today let's jump on into our equations. Okay, wait, here it is right here. Okay, let's get started. Okay, our lesson today is solving equations containing rational expressions. And in blue, I have some examples of equations containing rational expression. X over 2 plus 8 over 3 equals 1/6. That's an equation containing rational expression. Because remember, rational numbers are basically fractions. Here's a fraction, here's a fraction, here's a fraction. That's why it's called rational expressions. Here's a very long one. We have 4x over x squared plus x minus 30 plus 2 over x minus 5 equals 1 over 6x plus 6. That's a rational expression equation. And that can be solved. And that one I just the other department, that's gonna be tedious. You have to factor this, and it gets very, very, very involved. Now, objective is to get rid of the fractions. As I have experienced, I have told my students every time that students do not like fractions. And that's why I like this lesson, because if you don't like it, you can get rid of it. My thing is out of sight, out of mind. And with all these, with these two examples, they're fractions, and you can solve this, but first you got to get rid of the fractions. And like it says in the parentheses, you have to eliminate the denominator. And today, that's what we're going to look at, how you solve these by getting rid of the denominator. And once you get rid of the denominator, there will simply be equations that you have done in the past, where you just solve for the variable. But the first thing is to get rid of the denominator. So, and to get rid of the denominator, in order to do that, you have to multiply each term. Here again, now let's go back up a minute. In this particular expression, this equation, there's 1, 2, 3 terms. So I would ask my students, how many terms do you say? 3. I said, so how many times are you going to write the LCD? 3 times. And that is so important. You have 3 here as well. So when you factor and find your LCD, you would multiply each one by the LCD. By doing that, it helps you eliminate the denominator. Okay, so by multiplying by the LCD, it helps eliminate the denominator. Let's go ahead and make note of that. Multiplying by LCD. Eliminates denominator. Eliminates denominator. Each term has to be multiplied by the LCD. Each term has to be multiplied by the LCD. Here again, the LCD should be eliminated by the way of cross cancel. If it does not, that means you're not doing something correctly. In the end, all your bottom numbers should be 1. Because here again, by them being 1, that means there's no denominator. Okay, so let's go ahead and jump into our first example. And of course, I'm going to start off easy. Let's see, they did that one, so let's do a different one. Okay, here, x over 4. We can do the one that's up there. So it's x over 2. X over 2 plus 8 over 3 equals 1 over 6. Okay, we have 3 denominators, 2, 3, and 6. We need to find the LCD of all 3. So you ask yourself, what is the smallest number 2, 3, and 6 can go into? The smallest number that 2, 3, and 6 can go into is 6. So my LCD is 6. Okay, I said right here, it says multiply each term by the LCD. We have concluded that LCD is 6. So what I'm going to do, I'm going to write my LCD in orange. And because we're dealing with fraction, I just go ahead and write it as a fraction. Because we're dealing with fraction, I'm going to write my LCD as a fraction. So I'm multiplying each term by the LCD. Multiply each term by the LCD. The LCD is written in orange. Cross canceling is the key. Cross canceling is the key. Cross canceling is the key. Because cross canceling, you should eliminate your denominator. All right, let's cross cancel, shall we? Dun, 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 dun. Okay, let me move the screen up just a tad here. Okay. We're gonna look crisscross. We're look, okay, here again, let me point this out. There are 3 terms. So there's 3 different sets of problems that we have to do some canceling and crossing out. Okay, we know 2 goes into self once, it goes into 6 3 times. As not to be confused or have a mess going on, let me suggest, we know there's a plus sign right here, so go ahead and bring your plus sign down. We're working on the left side, so let's look at our denominator. As I said before, both of my denominators are 1, so that was what I was trying to achieve. So I'm going to now have 3x, because 3 and x are not crossed out. So that's what I have on my left side of my plus sign. I'm going to cross cancel again. 3 goes into itself once, it goes into 6 twice. Here again, my denominators are 1, and that's what I'm trying to do. Get 1 in my denominator. I'm going to multiply 8 times 2, which is 16. 6 divided by itself is 1. That cancels that. There's not 0 over there. It's 1. 1 times 1 is 1. See, now you have no fractions. No fraction. And like I said, this is solving equations where you should know very well how to do this. Now we're going to solve for x. So I'm going to subtract 16 from both sides because I'm going to do the opposite of what I see. And I tell you, these must be opposite or you know you're not doing it right. I have 1 minus 16. I cannot take 16 from 1. So I also say when you take a big from a small, your answer is definitely going to be negative. I'm going to bring down my 3x. This was a 2-step equation. I subtracted. Now I'm going to divide both sides by my coefficient, which is 3. And x equals a -5. Integer rule, dividing unlike signs, your answer is going to be negative. Now, let me show you how to check this. Okay, x is -5, correct? So that's -5 over 2 plus 8 over 3 should equal 1/6. In order, you already know 1/6 is a given. So we need to find the LCD for these 2 over here, and of course, the LCD is 6. 3 times 2 is 6, so 3 times 5 is -15. 3 times 2 is 6, 8 times 2 is 16. And when you combine, -15 plus 16 is 1. I mean, both sides do check, so you know your answer of x equals -5, which is right here, is correct. So it's very easy to know that you're correct if you take time to check your answer. All right, that was one of the simple ones. Let's move on to something that's more involved, shall we? I found one. Here we go. T minus 4 over 2 minus t minus 3 over 9 equals 18. 5/18. My eyes playing tricks on me. All right, my denominators are 2, 9, and 18. The LCD for 2, 9, and 18, of course, is 18. So, and I have 3 terms. I have one here. The whole thing is a term. I have another one here, and I have another one here. That means I'm going to write my denominator 3 times. And here again, because we deal with fraction, I'm going to write my denominator as a fraction. I don't know if I'm going to run over or not. I'm going to put up here just so I have room. Notice I have 3 terms and my denominator was written 3 times. So let's bring down our problem now. We have t minus 4 over 2 minus t minus 3 over 9 equals 5 over 18. So my original problem is in orange and my denominator is in black. Now I'm going to cross cancel. You cross cancel before you do anything else because we're trying to get rid of the denominator. We want everything on the denominator to be a 1. So 2 goes instead of 1, so it goes to 18 9 times. So if 9 times t is 9t, 9 times 4 is a negative 36. 9 goes instead of 1, so it goes to 18 twice. Minus 2t 6. It goes at 1, so it goes at 1, and I'm left with a 5. Yes, no, maybe, tell you tomorrow. Do, 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 do. Oh, I already multiplied. Oh, so they do it differently than I do. It's all good. Now, if you want to, you can do this. So you can see that a negative is going to affect everything in the parentheses. And I think we talked about that before. The second expression, it needs to be in parentheses so you can show that a negative sign affects everything inside. Okay, so when teaching this lesson, it is suggested that you get rid of the parentheses first. So we have 9t minus 36 minus 2t plus 6 equals 5. Why? Because this subtraction sign is right here. And this minus sign is right here. But because it's an expression, it's placed in parentheses, telling us that there's a negative 1 out front, so we need to distribute. Now we're going to combine like terms. We have a 9t and a 2t. We have a constant of minus 36 and a constant of 6. I identify my like terms with like markings. That tells me those are 2 things I'm going to combine. 9 minus 2, of course, is 7. Negative 36 plus 6 is going to be a minus 30. And all that equals 5. So now we have 7t minus 30 equals 5. We have to solve for t. I have a 2-step equation. I see 2 operations. That tells me I'm going to take 2 steps to solve it. I'm going to do the opposite of minus 30. So I'm going to add 30 to both sides of my equation. And when that is done, and I have 7t equals 35. I still need to get t by itself. I see multiplication. I'm going to do the opposite. So I'm going to divide both sides by the coefficient, which is 7. And therefore, t equals 5. Let me share this with you. Do you know that this t can be placed anywhere in this problem and still be able to check it? Like if I didn't want to go back to the original problem, which is fractions and what have you, I could go right here where I've already changed an equation and check it. I can go right here. And this is the easiest one because 7 times t or 7 times t, which is 7 times 5 is 35. 35 minus 30 is 5. So either way, it's correct. So that was not too bad. Let's see if we can find one that even going to be even more of a challenge for us. Oh, there's one. We have 3. 6x. We got to see what she got left. Haircut equals x plus 8. What do you notice about this particular problem? It's not quite like the others we've done. So you have here again, be observant. Notice only one denominator. Only one denominator. So if you only have a one denominator, what is a given? In math, this means therefore. One denominator, therefore, that is the LCD. Because you only see one denominator, it can't help but be the LCD. You can't create other denominators. So one denominator tells me that is the LCD. I'm going to still do what I've done in the previous problems and multiply each term, and I have 3 terms. So each one's going to be multiplied by x. Now, 3 is an integer, so I do not have to write my x as a fraction. But my second term, that is a fraction, so I'm going to write my x as a fraction for that one. This is the last unequal sign is an expression, so I don't have to write a fraction for that x as well. So here again, because it's not a fraction, I do not need to write it as a fraction. So we're now going to multiply each term by a denominator, which is x. I'm going to multiply that times x minus 6 over x equals x plus 8. And remember, you're multiplying, so you want to make sure they show multiplication, because written like that, it looks kind of, So by doing this, we know we're going to be multiplying. So here again, we still have a denominator we need to get rid of. So let's do that. This is going to cancel with that. Of course, it's a 1 here, and that's like a goal to get 1s in that denominator. Eliminate the denominators. Let's multiply. 3 times x is 3x. Minus 6, because the x is gone. Notice on the right side of the parentheses, excuse me, equal sign, there's a distribution process to happen. X times x is x squared. 8 times x is 8x. Now, I tell students all the time, the minute you see a square, you think quadratic. When you see a second degree, think quadratic. Think quadratic. That's how you have to solve. Think quadratic. That means you have to have your prior knowledge of a quadratic equation. Think quadratic. Oh gosh. Quadratic. Oh, that's not looking cool at all. Think quadratic. Quadratic. Like drastic. Call for drastic measures, quadratic, okay? All right, because I have a second degree term, I need to think quadratic. So I need a set equation equal to, can I hear you? 0. Set equation equal to 0. Whenever you think quadratic, set equation equal to 0. That means you need to be everything over on the right side, because your second degree term cannot be negative. So that means I'm going to bring the 3x over. I'm going to line up right here with the like term. I'm going to bring the 6 over. There's not another constant, so I'm going to just put it by itself. These equal 0, so that's a 0 I was needing right there. I'm going to combine those like terms. It's going to be 5x plus 6. Now, some of you get a little uneasy when it's written with the zeros in the front. If you want to rewrite it where you have 0 on the other side, it's the same thing. Meaning if you want to do it this way, x squared plus 5x plus 6 equals 0. Same thing. When you end up with a quadratic, to solve, you're going to factor. You have to factor each factor. So let's factor. It still equals 0. We're trying to get 5 in the middle. 2 factors of 6 that gets 5 is going to be 2 and 3. Everything's positive, so both parentheses will have plus. You're going to set each factor equal to 0. Set each factor equal to 0. And how do you do that? Like this. Your first factor is x plus 2. X plus 2. So that equal to 0. Your next factor is x plus 3. Set it equal to 0. Now solve. Minus 3, minus 3. So x equals negative 3. Minus 2, minus 2. X equals negative 2. Now, let me tell you a little secret. 9 times out of 10, or sometimes you may have it where they will not, both of them may not work. So it behooves you to check to see if they both work. Now here again, you can go right here and see if they both work, or you go back to your original problem up here and see if they both work. So it is possible. Let me see who's going to take, let's see, I can do it right here. Negative 2 squared is 4. 5 times negative 2 is negative 10. 4 plus 6 is 10. So negative 10 equals 0. So the 2 works. Negative 3 squared is 9. 5 times negative 3 is 15. Negative 15. Negative 15. 6 and 9 is 15. So the negative 3 also works here. So that means my answers are correct. But here again, I can do it orally, but you need to go back and actually write it down and make sure, see if it works. Okay, I didn't expect that one to come up so soon, but it's okay. Oh, you did it. Okay, I think we have one more before it's all over, Rover. So let me go into this other one. I do have 2 more, okay. Okay, tired of black. Black. Green, how about green? Okay, we have 4x over x squared plus x minus 30. Plus, oh, this is like one of the long ones we had earlier. 2 over x minus 5 equals 1 over x plus 6. First you want to do is factor to find LCD. All right, of course, there's only one to be factored, and it's the trinomial. So let's factor the trinomial. We're factoring x into x and x. We need 2 factors of 30. It's going to get 1. Of course, that's 5 and 6. Because the middle number is positive, we want a bigger number here to be positive. We have to get a negative 30 and a positive 1. So we factored. So what is our LCD? Let's go ahead and put it. Remember we said we're going to write an LCD right here. LCD, we did this earlier. Okay, what? They all don't have anything in common, but the LCD is 6 x minus 5. That's the LCD. So as I said before, you have to multiply each term by the LCD. So, and I also say, remember when we do add and subtracting, once we factor, we don't consider the original anymore. We're looking at the factored form. So our LCD is x plus 5, x plus 6. And at 3 terms, so we got to write it 3 times. X plus 5, x plus 6. These problems can prove to be very lengthy. Okay, all my LCDs are written in orange. I'm going to write my original problem in green. Okay, the first one of my problem was 4x over, I'm going to leave it in factored form. X plus 5, x plus 6, plus, we're multiplying times 2 over x minus 5 equals 1 over x plus 6. So my original problem is in green, and my LCD is in orange. Remember, we're trying to get all our denominators to be 1. So now we need to cross cancel. Let's start over here. Okay, this is going to cancel with that. Okay, I'm going to right side of my equal sign. What do I have left that's not crossed out? X plus 5. Now let's go to the middle. This is going to, oh, did I write that wrong? Yes, I did. This is a minus. 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 It's a minus. It's a minus. This cancels with that. So now I have 2 times x plus 6. The x minus, this is going to cancel with this. This is going to cancel with that, leaving me with 4x all by its lonesome. My plus sign. All right, let's go back. First thing we did was factor this trinomial into x plus 6, x minus 5. Doing that, it helps me come up with my LCD. Then down here in orange, I wrote my LCD in orange. X minus 5, x plus 6. X minus 5, x plus 6. X minus 5, x plus 6. Then I went and I cross canceled. The x plus 6's canceled out over here, leaving with x minus 5. The x plus 5, x minus 5 canceled this, x minus 5, leaving with x plus 6. And I had a times 2 right there. That's where that 2 comes from. The LCD is in the first expression, so it took away the whole denominator. There was nothing left. So now I have 4x plus 2 times x plus 6 equals x minus 5. So I'm going to go ahead and combine. That's 4x plus 2x plus 12 equals x minus 5. So I just combine like term. I distributed. Right here, distributed. Distribute. I'm combine like terms. Combine like terms. Combine like terms. So this and this can be, look, oh gosh, can be combined. So that's 6x plus 12, almost done here, equals x minus 5. Now collect like terms on same side. Collect like terms on same side. Collect like terms on the same side. That means I need to get all my x's together and all my constants together. So let's do it. So I'm going to move my x over here. That means I lost something on that side, so I need to move my 12 over here. And I lost something on that side. I love the way I do this because it shows that my equation remains balanced because both sides lost something. And that's why I try to show students this approach, you can visually see that both sides lost something, so the equation remains balanced. 6 minus 1 is 5x. And of course, you're adding like signs is going to give you a negative 17. X is not by itself yet, so we need to divide by the coefficient, which is 5. And those cancel. And our answer is negative 17 fifths. Bum, 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 bum. Bum, bum, bum. And we're done. How you like me now? All right. Any questions? Okay. I think I got one more. One more. Okay, let's see. 2x over x minus 4 equals a over x minus 4 plus 1. All right, lucky you. What do you notice? The denominators are the same. So we don't have to find LCD, but we still have to multiply each term by the LCD in order to get the denominators to go away. So we're going to write x minus 4 3 times because there are 3 expressions. So there's my my LCD. I'm going to multiply it by 2x over x minus 4 equals 8 over x minus 4 times that plus 1. And I'm going to go ahead and put my denominator as a fraction since I'm dealing with fractions. And we're ready to cross cancel. This cancels with that, leaving me with 2x. This cancels with that, leaving me with 8. And here, because it's an expression, it's going to be for the parentheses. I'm going to distribute the 1 as x minus 4. As before, I'm going to collect like terms. I have 2 constants that can be put together. That's 2x equals 4 plus x. Because I combine 8 minus 4, and that's what's left. All right, let's solve by taking the x over to this side. So 2 minus 1 is x, which equals a 4. Now, let's check. We haven't checked all of them, but here again, it behooves you to check. Now, here again, ladies and gentlemen, as a math student, you have to be observant. Now, when I solve this problem, I have a solution of 4. If you look at your original problem right here, this is your denominator of the original problem. See, that's your denominator. So if you're telling me that x equals 4, and I was to plug it in here, what is 4 minus 4? 0. And when 0 is a denominator, it means it's what? Undefined. So even if you don't go all the way back and check it, you need to. You need to. Because it's not always going to be what you think it is. Because because 4 will make original problem undefined, will make original there's no solution. So checking is going to be essential to making sure that you have the right answer. So if you put 4 on the line, your answer is going to be incorrect because you didn't go back and check and see that 4 is not going to work in that problem. In other words, it's going to give you an undefined answer. Okay, so please be careful. Okay, any questions, comments, or concerns? Did I do it with 4 terms? Oh, I have one with 4 terms. Give me a second. Let me get some more paper. I found one that has 4 terms in it. Yay, Miss Campbell. All right, we have x plus 14 over x minus 2 equal 7x over x minus 2 plus 1. Ooh, the good thing about it is it already has the LCD, so you don't have to do too much work. But you're still multiplying each term by the LCD. All right, we're going to write LCD in black. That's x minus 2. X minus 2, that's my LCD. X minus 2. And x minus 2. LCD is in black. Okay. And we know that we're going to multiply each one. Our first term is x. So we're going to multiply this. It's going to put it in parentheses because x stands alone. And we don't want to look like it says 2x. We're going to put it in parentheses plus 14 over x minus 2 equals 7x over x minus 2. Remember, that's in the numerator. That's in the numerator. Plus 1. And here again, we're going to use parentheses so we can show it as it's an expression. So here is our LCD, 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 because there are 4 terms. Here's my original problem in yellow, x right here. 14 over x minus 2 is right here. 7x over x minus 2 is right here. And we have our 1. So our original problem is in yellow, our LCD is in black. Now we're ready to cross cancel. All right. The first term is not a cross cancel, but we can cross cancel right here and right here. Here we can cancel with this and with that. And those are the only 2 fractions in our problem. So those are the only 2 that actually can cross cancel. Give me all 1s in my denominator, and that's what I need. Now let's distribute. We have x squared minus 2x plus 14 equals 7x plus x minus 2. How did I get that? X times x is x squared. 2 times x is 2x. 14 has nothing to multiply by, so it comes down. 7 has nothing to multiply by, so it comes down. I'm going to distribute my 1. 1 times x is x. 1 times 2 is 2. Now I'm ready to come by. Oh, ding, 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 ding. I see a second degree. That tells me quadratic. I see a second degree, so I see quadratic. Quadratic. So that means I need to get equation set equal to 0. So that means we need to bring everything over to one side. So in order to do that, I'm going to subtract 7x from over here. I'm going to line up with this because they're like terms. I'm going to, before I do that, let me go ahead and combine my, well, either or. Should I come into 8? It'll be 8 minus 8 is going to be minus 6. Let me go ahead and combine my like terms first. That's what I usually do. I combine like terms and then combine like terms and then take it over. I see a quadratic. I'm going to combine my like terms and then get everything set equal to 0. I think it works better that way. So it's going to be 8x. Kind of need some ink, don't I? That's 8x minus 2. X squared minus 2x plus 14. I'm going to bring my 8 over by subtracting 8 from both sides. That cancels with that. I'm going to add 2 to both sides to bring my 2 over. I have 0 where I want it. That's x squared minus 10x plus 16 equals 0. That's my quadratic. I'm going to factor. Oh, if it's 6, that's 16, my bad. What 2 factors of 16 is going to give you 10? X, 8 and 2. 8 and 2. I need a positive 16 and a negative 10. When they add, it should give me a negative 10. So that means they both need to be negative. When they multiply, they got to give me a positive 16. Negative 8 times negative 2 is negative 16, so I know I factored it correctly. And as we did in the previous problem, we said each one equal to 0. X minus 8 equals 0. X minus 2 equals 0. So x equals 8, x equals 2. And we are done. Simple. Well, we have done it. We have braved the rapids. We have tackled rational expressions. Whew, that was a journey. We have simplified, we have multiplied, we have divided, we have added and subtracted with like denominators, we've added and subtracted without like denominators. Whew. Are you as exhausted as I am? But I really enjoy this lesson. I really like giving students the easy way to look at math instead of, using terminology that they still don't understand. That's why they come for help. So I hope that everything I've done and said has been very helpful to those students that are having trouble. We enjoy bringing this to you. Please make sure that you are trying your best to be the best you can be in your math class. Use all resources available because me personally, I want you to be the best you when it comes to math. I love math. I still think something's wrong with me because I like math, but it's a challenge of it all just to see that, oh, that was easy. And that's why I try to make it easy for my students. It was a pleasure sharing these lessons with you. I hope you do well in your math class. I wish you nothing but the best. I ask that you stay safe in times like these, and please always think positive. You have a great one and you be safe.